So Kenichi, please take it away. Thank you.
Yeah, thanks, Mark. Can you hear me okay?
Yeah, we can. Thanks.
Can you see my screen as well?
Looks brilliant.
Good, good. Thank you very much. So I'm Kenichi Soga from UC Berkeley, and the previous talk was fascinating. So thanks a lot. And my talk is a little bit more generic, so I hope that you can cope with that particular part of the nature of this particular talk. This is called Emergent Technology for Infrastructure Resilience, and it really comes from our ASC Infrastructure Resilience Division Emerging Technology Committee that your colleague, Professor Reda Taha, is part of that particular. We co-chair together. So what I'm going to present is something that came out from this particular committee, and trying to identify what's the value of emerging technology. How do we introduce these technologies into the market? And what are the barriers and that sort of thing? And what is the pathway forward? So just to give you a little bit I work on the infrastructure sensing side, more on the movements and that sort of thing. So you see a lot of emerging technologies coming. You probably know about computer vision, LiDAR, and UAVs, satellite monitoring, distributed fiber optic sensing. This is where I focus my research on, or WSN wireless sensor, which is continuous monitoring at difficult. So you see this technology have been bursting in the past 10 years or so. And the reason why we like this is coming to the level of sort of a 10 millimeter or sub-millimeter level that we as an engineer like to see. So it's really this precision of the data is coming to the precision that we want in terms of our engineering design. That's why these technologies are really coming up. And you can see typically we have this tech hype cycle in terms of initially it's an innovation, you get a hype, but then many people not get interested, and goes down, but some technologies start to go up, and that's a typical tech cycle. But you can see like LiDAR and wireless sensor network and drones, we already see that really coming up into the market. But then we see like fiber optics or satellites start to turn around. But 3D printing or other AI machines start to have a peak and start to move around. And this is where we want to see how do we motivate ourselves to adopt these technology in actual infrastructure problems. Now, the challenge we have in terms of infrastructure is that we tend to design our infrastructure for 100+ years. So that is the framework that we already have, which may need to change, but then actual life of infrastructure may go forever depending on the demand. But if you see many, many cities around the world, and of course, any place that you live, there's an actual change in demand 40 years because of the economy, how the social demographic changes, and many things happens. So the cycles that we use the infrastructure is much faster. So we really want to make our infrastructure more adaptive in terms of change. And can we change from infrastructure designed to be rigid to be 100+ years to something more flexible? At the same time, when you see this technology, they don't last for a very long time. So what are the technology that can be sort of prolong the life so that we can monitor things for a long time? So our infrastructure is very fixed in space for a long time. That makes them critical as urban setting changes more rapidly than the life of the infrastructure. And then the fixed infrastructure for a long time may contribute to social inequality. You may see that having this infrastructure so good for 120 years may give some social inequality in this sense. And so do we need to change our infrastructure design to be more adaptive depending on demand change? So when we look at infrastructure, we tend to look at accidents. So you see the operation, then you see a bad accident, and then you say, oh, we got to do something about it. And the spirit of this was, let's do factor safety, do some probabilistic analysis based on the assumed failure mechanism to avoid this, make sure that we die so this may not happen. But then the point here is that in the past, it was too expensive to monitor things, how things are going daily, to continuously maybe monitoring, but maybe not now. But if you just go back to what is our typical way of designing things, is that we do, so like this is in earthquake in our Bay Area, we do like Hayward Fault earthquake and look at earthquake scenario, probabilistic way of looking at it. We look at the failure mechanism, pipeline damage, and we do water network simulation to see how much water shortage you're going to have if there's an earthquake, but it has to be probabilistic, so you have some standard deviation, and based on that you design something and like this. And that is a way we tend to do in terms of how we cope with resilience, which is very good, and we establish ourselves. And we also look at the interdependency in terms of building damage and traffic disruption with a base of large data set that we can get now and do a high performance computing. We can do this much easier than in the past 10 years or so. But if we look at managing safety by everyday work, in a sense, can we use our sensor to understand how our infrastructure is performing, and how do you monitor and learn and anticipate and respond? So by doing that, you may be able to think about what is a threshold it is in terms of unacceptable performance, because we often don't do that in the previous risk-based method. So by understanding how it performs, you may be able to stop the accident. So if you know the actual performance, you can learn how to react quickly if a disaster starts to happen. And we can cope with the future unknown demand, and then find any potential improvements like improved design or construction process. So these all make sense if you think about it, but then the question is that how do we embed this in intelligence in our system so we can monitor, learn, anticipate, respond for the infrastructure that you design and then you're operating. So this comes from a little bit more on the social science area, is monitor what we in your could change, and learn from experience, learn the right lessons, and then you anticipate the threats and opportunity for further opportunity to improve in the future, and then respond to any regular or irregular variability, disturbance, and opportunities. And that's what we want to see more to happen. So for example, you may do that kind of simulation, more probabilistic simulation, but then we start to implement it sort of intelligent to our systems. For example, this is the pipeline that was replaced that's crossing Hayward Fault, which have a very high probability of failure of earthquake in the future. It is creeping in order of 5 millimeter per year. But here we're going to install a distributed fiber optic system where we can monitor the actual performance of these pipelines. Otherwise, we're not going to just bury it and we're not going to see for another 120 years because we build it and then we don't see it. So how can we embed the intelligence on our system? But there are a lot of barriers to adoptions. For example, there's a public mission that many companies have in terms of reputation. You don't want to lose reputation for service quality. So you don't want to take any risk of adopting new things. So, but you need to show savings, but sometimes it's not very clear what the saving is going to be because it's going to be 100 years design life. So you start to work with small pilots with small impacts, but you really need to start finding the first movers. And that's what we're trying to do, is that we need to work together. Long-term stewardess is really an important one because many companies' infrastructure lasts for many, many years, 100 years. So typically people don't want to use startup companies because you don't know they're going to last for another 100 years. So that means that you want to vendor that will last a very long time. And that's a challenge. So we tend to use a technology that has established in other industries, but then we go for established vendor because you want to make sure that they last for a long time. The third one is a labor. There are generation gaps in delaying labor skill development. You want to implement, but then there's a skill that you can use it. So there's a strong resistance by the sort of a workforce using this particular technology. So my experience is that you're trying to adopt technology that enhances worker safety usually works very well because that enhances their interest to make sure that the infrastructure is monitored, but then also increases their safety. And then we need to work with employees to adopt new technology. And that's something that is barrier. There is a barrier there. And of course, we know in the infrastructure engineering, it's very, very siloed. It's siloed because it compartmentalized, because it's rigid, but it's also rigid to be strong. But then because it's siloed, there's a complex interaction in a sense that you want to introduce a technology, but then there's a government who's providing the funding, but then you're doing the service to the public sometimes. And therefore there's a rigid, but it's resilient in a certain way, but can be brittle. But how do we embrace this particular technology into this complex society? But I think the digitization of what we're doing in terms of construction will start to make that happen. So we need to show the value. It's not the product that we say. I think the previous speaker spoke about what is not the product, it's really the value, and that leads to confidence in delivery. And the value is defining the values, providing the equity in terms of you have a better cost and more efficiency. You gain the gains from the employee, you give the safety and job satisfaction to the employee of using this technology. And then our challenge as a civil engineer is really high quality service throughout the long life of infrastructure. How do we get that? So these are the drivers. So within our emerging technology committee, we were thinking, and then of course we start with some sort of a framework, which you know very well in terms of performance versus time. And then if you don't do anything, it's a red. You start to degrade your infrastructure, and if something, a natural hazard happens, it goes down. But then you have a limited recovery because they don't have robustness. It takes time to respond. And then you have a slow recovery period. But then you have, if you do resilience technology, you may do better in terms of make sure that you know your infrastructure better before. And that's what we call resourcefulness. When it goes down, it doesn't go down as much. That will be robustness. And then you recover quickly. That is a redundancy. And then you respond very quickly in terms of responsiveness, making this shorter, and then you quickly go up as a rapidity. So we all know these sort of 4 R's and 5 R's in resilience sort of framework. So what we did in the committee is to try to look at that 5 R's and what is the value of each technology providing the contribution to that 5 R's. So you really give the value of adopting emergent technology, improve the resilience. First, you need to identify the scenarios, right? You need to think about that very carefully. You can learn by monitoring to identify the scenario. You have to anticipate and then predict what's going to happen. Anticipation is very important. And you identify possible system disruption, and then examine the component and subsystem and examine the effect of the whole system. So you do this, but then by monitoring each other, you start to build the anticipation what's going to happen. And what you do is that you really want the emergent technology providers to work together with infrastructure owners to go through some questionnaires leading to this 5 R's. And we hope that by doing that, there's a better dialogue between two parties or parties that involve with infrastructure development. So I'm not going to go much in detail, but you start with this particular one and you go to a certain questions. And as you go through the question, you categorize the technology, and then you sort of see what are the technology contribution in the second row, and you go through that. So within the committee, we went through variety of technology, but just to give you an example, this is like does technology gather information about system operation? Is technology embedded into the system? So going through the question, you go through that flow chart, and then you go through the technology characterization questions, and then you go through all these 5 R systems. So we did this exercise with our colleagues. So this is like 3D printed post-tension temporary concrete bridge, which are really good for recovery. Shape memory alloy-based control devices to improve the sort of control of the system. And then these are more sensors. This is another sensor. There were a lot of sensor technologies. There's a 3D digital surface model that we may see many of those in this particular colloquium. Using machine learning for sort of using UAV image to identify which buildings are damaged, or using sort of augmented reality or virtual reality devices to appreciate what is going to happen with a nuclear power plant. Or you can look at the resilience of microgrid, which is going to a small island. So there are very variety of how do this technology keeps the resilience. And what we have found out is that we went through all these technologies. So we went through all these technologies. So you can see all these technologies that we identified. And then when we look at all these things coming back and forth to find out which technologies gave you what R's. And interesting enough, we found a lot of technology that will go for resourcefulness, really trying to monitor things better. We found a lot of things in responsiveness, how to shorten life, because there's a lot of monitoring technologies available right now. But we had less so in terms of how do you do rapid recovery, or how do you make it redundant? What are the emergent technology rather than just make it stronger or make it structure redundant? What are the new technologies to make things redundant? Or what are the technology that can make it more robustness? We see a lot of opportunities because there are not many people working on this. So my point here is that if you're a new researcher trying to make something new, probably going through these kind of robustness, redundancy, rapidity, there's new areas of research, I think, from my point of view. So to provide resilience and sustainable infrastructure for current future generation, by using technology, we need to show the value of proactive actions rather than reactive actions. You sort of monitor, learn, anticipate, react. So that needs to be part of the design philosophy. That gives you what we call performance-based design and operation. And that will give you the value for improved recovery because you're learning as you monitor your infrastructure. And we really need to make a market. We don't want to finish by saying, okay, I put the sensor and I'm happy and I write a paper and finish your research. We really want to bring it into the market. So we need to make what we call smart infrastructure market. And that's, we need to understand what are the barriers to it. So building trust with infrastructure owners and community members are very important. And that's where the value proposition is. And we sort of start to create that framework that you saw. It's not perfect, but we're trying to see how that can define the value. But at the same time, providing equity and giving safety and job satisfaction does help to the workforce to introduce the technology. So that's something we need to think about. And the final challenge we have is that our infrastructure is going to last very long. So we have to ensure that our quality is high service for a long time. And how do we make that happen, but can be adaptable? So that's it. Thank you very much.
Excellent. Thank you, Kenichi. It was a really nice presentation. I like the level that you came in at. I could follow it. That's good for me.
Thanks.
So it looks like we've got, no, I guess those are still clapping hands. So as the clapping hands disappear and people turn those into raised hands, I'll start us off. So you'd mentioned that this is associated to some degree with the ASCE resilient infrastructure work that's been going on. Could you talk a little bit about that and how your work relates to that, or what that committee's mission is, and how people can get plugged into the products that are coming from that group?
Yeah, so ASCE has an infrastructure resilience division, which is one of the groups that we're interested in infrastructure resilience. And then your colleague Mahmoud Redtar is one of the leadership in that area. Now I chair the Emerging Technology Committee, but there are other committees. So if you go to their website, you can join. And then once you join, you can be as an active member of the committee, or you can see what's going on in that particular one. And Emerging Technology Committee, when I grabbed this chair sometime a few years ago, we started to say, what can we do? And we felt that we need to start showing what's the value of emerging technology so the infrastructure owner starts to adopt. And the outcome of the recent is the one that I show you today.
Excellent. Thank you for giving that perspective. I'm not seeing any other hands. Do we have any other questions from the crowd? We've got a lot of people doing work, at least somewhat related to this. Looks like one popped up. Maggie had one in the chat. She's asking if you work with people involved in green chemistry. It seems like an emergent,
green chemistry. Yeah. Oh, I want to know more about that. I know green infrastructure, but I'm not sure I understand the green chemistry.
I don't know that much about it either. I don't know if Meg, if you're available to expand on that.
Okay. Well, I'm trying to think of the guy that is the head, but there's a green chemistry initiative, and right. It's basically to use chemicals that are already proven safe in right. to do things, right? And so one of the things they've done is they have a sealant for highways, asphalt highways, that is much cheaper than like putting in a new road. Yes. But as you're thinking about these technologies, even the sensors or the something, I think be able to add green to this, you might. I think it might be a useful thing as well as a good a good way of marketing it. It just seemed like you're using a lot of metals and those sorts of things. And I love the concept of, anyway, I will send you the name of the person that I know, I can't think of it right this minute, but he's head of a new department or Institute of Green Chemistry. And
that's
so
really...
it's something to keep in mind, I think.
Yeah, that's a very good point. And I think the problem with our infrastructure is that we said, please last for 120 years. So let's say you attach a sensor, you got to use certain glue that will last for 120 years. And that really restricts us to use certain hazardous chemical, for example. But if the design becomes a little bit more flexible, then potentially this green chemistry will allow us to introduce. And that's a really good point.
Yeah, and it's so easy to kind of be siloed and never hear about these things. We're all so busy and so much is coming towards us. Anyway, good.
Nice. Thank you very much.
That's why we do these things, Maggie. Get everyone together so we can share ideas. I see that Carletta, Dr. Chief, do you have a question for us?
Yes, fascinating talk. Thank you. I was really interested in your bullet point with number 1 and 2, building trust with infrastructure owners and community members, and then a framework to start this dialogue. So to give you a little bit of background, I'm working with tribal communities on off-grid water, greenhouse, solar technologies. And one of the things we're looking into is what people
I may have lost the voice. Is that correct?
Yeah, I think Carletta locked up on us, unfortunately. I'm not sure where she's calling in from today.
Oh, I see.
All right, so maybe looks like we lost her altogether. So we'll try to circle back to Carletta. Hopefully she'll be able to get back online.
Okay.
We can take a question from Jake quick.
Yeah, great talk. So I developed a new technology through my research, and I'm sure you've encountered this in this, something called loss aversion, or the devil that you know. Have you encountered that in your research, and how have you come over it?
Can you a little bit define devil that?
Loss aversion, or the devil that you know, you don't want to try something new because what you've been using for so long, it's been so ingrained and embedded into the infrastructure that you don't want to try something new, even though it may be better, but you don't know it's better yet. And so you rather stick with the devil that you know, the older technology, than try something new. Have you encountered that in your research, and how have you come over it?
It's all the time, I think. And I think changing the material like concrete is a really big impact, right? But then it's been a difficult one because it's normal things that we do. And perhaps the design life of 120 years really fixes us to use certain material. And maybe, and it's really more of a civil engineering as a whole problem, or it can be political decision-making process problem too. And so I think unless we change that, it may be difficult to introduce. And I think the only way I can see is really working together with infrastructure owners and community to make that happen. It has to be gradual change. It's my only. As long infrastructure lasts for a long time, our implementation will last a long time too. But yeah, I'm trying not to give up.
No, exactly.
So sorry, I'm not answering your question, but then I think the value proposition is very important. And sometimes you come from certain area, but then today I was trying to show you can come from different angles and package it the way you can introduce your technology, not just looking from one angle.
Exactly. Yeah, I found multiple angle approach definitely is beneficial to penetrating existing markets. Is definitely beneficial. But thank you. Great talk.
Yeah, thank you, Jay.
Great. And in the meantime, thanks for that question and that answer. There's a couple of quick ones that popped up. One, I think Carletta's still having connectivity issues, but she did pose a question in the chat to, I guess, wrap up what she was saying earlier. And that is, Kenichi, do you have any experience in, or any experience that could elucidate the perception of the role of communities in adapting new technologies, and especially dealing with indigenous communities. Do you have any experience along those lines?
No, I don't have the experience on that particular one, but I think it's becoming really important issue, and I start to realize that more and more is that if we create a very good infrastructure for 120 years, that will create a social divide in a certain way, because the way that policy enhances, because you have a good road, allows you to travel long distance, and that will create a community divide, something like that. So I think learning more about the duration of infrastructure, talking with the community, may allow us to think a little bit more carefully on this particular issue. So I think maybe the discussion while doing the innovation about infrastructure is really talk about how long do you want this infrastructure to last, and why is it so, will be an interesting question to talk with the community members.